Alright, welcome back again. Transformations Unit Part 5. We're going to put everything together and use everything that we've learned so far in this unit. So on this first equation here, you'll see there's a lot going on. We have x is being subtracted by 3, and it also is being multiplied by 2. So there will be two changes on the horizontal as well as one change on the vertical, and that y is subtracted by 1. So when we put everything together, the first thing we identify is the parent function, which in this case is your quadratic y equals x. Everything is also grouped with x or y. There's nothing floating around on the x side that doesn't belong there, so we can go ahead and start our sketch. So we've identified the parent as y equals x squared, and we'll just see all of the changes that go into this function here. So we'll start with any reflections, and in this case there are no negatives. The minus 3 is not a negative, so that does not reflect, nor is the minus 1. So there are no negatives with this function, therefore there will be no reflections. The first thing that we are going to do is move our graph left or right. So how is the x affected? And remember, if it's subtracted by 3, it moves it to the right 3. So our parabola is shifted to the right 3 units. Now we'll take a look over at the y side and see if it moves up or down at all. And in this case, y is being subtracted by 1, so it's going to move it up 1 unit. The last thing that happens here is my x is being multiplied by 2. So that's going to produce a horizontal compression, which, as you can see, makes the graph skinnier. It's also going to have a new vertex. From 0, 0, it's going to change to 3, 1. So in this function, we had the graph moved right 3, up 1. It was horizontally compressed, and that made it skinnier with a new vertex of 3, 1. Here's another function, and in this case we have a negative, and we also have a plus 4 on the x side that doesn't belong. So we're going to get everything grouped where it should be. We're going to move the plus 4 to the y side. Since it's not in parentheses, I need to move it over. So I'm going to subtract 4 from both sides first, which gives me y minus 4 is equal to negative x plus 2 squared. The next step is dividing by negative 1 to get rid of that negative. Since it's not in parentheses, it really belongs with the y. So once I divide by negative 1 there, you'll see that my final ready to go equation is going to be y minus 4 over negative 1. You could also have it multiplied by negative 1. It really doesn't matter. And that is equal to x plus 2 cubed. So what's going to happen here? First, identify the parent and sketch a graph. The cubic parent function is looks like this. Now what happens to it? First things first, are there any reflections? And in this case there are. There's a negative 1 with the y. So a negative with the y reflects about x. And if you remember, for the cubic reflections, a reflection of x or y produces the same backwards graph. Now does it move right or left at all? And x is being added by 2, so that's going to move it to the left 2 units. What's happening with y? Y is being subtracted by 4, so that's going to move it up 4 units. Now you may think, okay, it's vertically stretched because it's being divided by negative 1, but 1 actually doesn't do anything. If you say, yeah, it's stretched by vertically by 1, well, that doesn't do anything, much like multiplying a number by 1 doesn't change it. So our final product is going to be with a normal cubic function. That means it's not wide or skinny, it's normal, and it has a vertex of 2, 4. So it's backwards, it's reflected, it's normal, and it's moved 4 units, 2 units to the negative, and 4 units up. I noticed there's a little typo on my slide here. This should be a -2. So the vertex is -2, 4. Take a look at another function, and this will look at an absolute value function. And in this example, we also have some stuff that doesn't belong. See, anything that's not in that absolute value needs to get moved with y. So I'm first going to add 2 to both sides and get rid of that -2. When I do that, I have y plus 2 is equal to -4 times absolute value x minus 5. I'm going to divide both sides by -4 to get rid of that because it's not inside the absolute value. So my final ready to go equation is y plus 2 over -4 equal to absolute value x minus 5. Let's sketch a graph. Parent function is in red here. And are there any reflections? Are there any negatives? I noticed there's a -4. So if there's a negative with y, it's going to reflect about x, which flips this upside down. X minus 5 is going to move this graph 5 units to the right, and the y plus 2 is going to move it 2 units down. Because the y is being divided by a -4, and in this case we already used the negative to reflect, so since it's being divided by 4, it's going to stretch vertically, which is going to produce a skinnier absolute value graph with a new vertex 5, -2. So there are some examples of putting everything together. I hope that helped. That concludes the transformations unit for now. And again, if you're in my class and this still isn't making sense or doesn't help, please feel free to stop by and get some extra help. Thanks for watching.